Hello everyone and welcome back to Zip Zip Academy, and today we are going to see about friction. So if you haven't watched part 1 of friction, please go and watch it. The link will be in the description. So in the last video we had seen about friction and what is friction and the types of friction and also the formula of friction. So today we're going to see friction on an inclined surface. So for example, this is an inclined surface and a body with mass m is kept on it. So there's going to be a weight force acting on it, which will be mg, a normal force which will be perpendicular to the surface, and yeah. So the value of normal we don't know, because in the case of a normal plane it was n is equal to mg, but in the case of an inclined plane n will not be equal to mg, because you can see that they are not opposite. So if we resolve mg, we will get mg cos theta. Okay, so we got n is equal to mg cos theta. Simple. Now let's see the other forces acting. If we uh, if we resolve mg, the mg on the y-axis would be mg sine theta, and over here will be acting friction, because you know that the body would be going downwards, so the friction would act opposite to the motion, and the acceleration is in this direction. So we can derive a formula by this, that mg sine theta minus friction would be equal to net force. Yes, because these are opposite forces, so if we subtract both of them, then we'll get the product as net force. So instead of F, if I write mu n, mg sine theta minus mu n is equal to ma. N's value is mg cos theta, so we're going to substitute it and we'll get the equation as mg sine theta minus mu mg cos theta is equal to mass into acceleration net force. If we take the m down, so we are going to get g sine theta minus mu g cos theta is equal to acceleration. Okay, so this came the formula for acceleration. A is equal to g sine theta minus mu cos theta. Okay, now similarly we can derive the formula for velocity, because we know the three equations of motion. V square minus u square is equal to 2as. Okay, so here we can take v as v. U will become 0 because it's starting from rest. Acceleration will become this. Let's take it as a. And s will become l. L is the length of the inclined plane. So we got the formula of v as v is equal to 2g l sine theta minus mu cos theta root. Understood? Which is this. So similarly we can find the equation for time. If you substitute in these values in the formula, s is equal to ut plus half at square, we'll get the formula for time too. Now if in the question it's mentioned that the value of friction is 0 or the value of mu is 0, then the modified equations would be acceleration is equal to g sine theta. If there is no friction on a inclined plane, then the acceleration will become g sine theta on an inclined plane. Similarly, you can take it for v. V will become 2gl sine theta under root, and t would also become same. Now let's see at some questions. So the first question, let's take an easy one. The length of a smooth inclined plane is 10 meters. So it's given that it is a smooth inclined plane, means there is no friction on the inclined plane, and its length is 10 meters, and the value of g is given to take 10 meter per second square, and the angle of inclination means this theta is equal to 30 degrees. Okay, and then they are telling to find the acceleration. So we had just seen the formula of acceleration on a smooth surface or with no friction, which was a is equal to g sine theta. Okay, and the value of sine theta, so sine theta is 30 degrees. So the value of sine 30 is 1 by 2, the trigonometric ratios you might have learned. So it would be 10 into 1 by 2, which is 5 meter per second square. So we got the acceleration as 5. Now let's take a difficult question. This is going to be a bit difficult, so you might have to take a pen or pencil for it. Okay, so the question says a 30 kg block is to be moved up an inclined plane. So there is an inclined plane and there is a body of 30 kgs, and the angle of inclination is 30 degrees. Okay, and the horizontal velocity is 5 meter per seconds, and they have written that the friction force which is acting is 150 newton. So find the force required to move the block up. Okay, the question is, so we have to move the block upwards. Yeah, so we know two forces act over here, mg sine theta, and one more force is going to act over in this direction because it's going upwards. So mg sine theta was always over this direction since the body is moving upwards, and then the frictional force will be over here too. So the frictional force will be mg mu mg cos theta. Okay, and here is going to be the force. So we'll get F is equal to mg sine theta plus mu mg cos theta. Okay, now if we substitute the values, F is equal to m is 30, g is also 30, g is 10, sine 30 is 1 by 2. Okay, and we know the mu mg cos theta's value. Mu mg cos theta is nothing but friction. So the friction value in the question is given as 150 newton. Now if we calculate this, the force which would be required would be 300 newton. Yeah, so the force which would be required to move the body up is going to be 300 newton. But there is more to the question. The question says that what will be the force along the horizontal. So this force we got as 300 newton. Now they are telling us to find it along the horizontal axis. So we know that the force would be F, because it's x axis, so it will become F by cos theta. Because it's acting upward, so we'll take by, or if it was acting in the same direction, so it will be F cos theta. So here we're going to take F by cos theta. So F came as 300 by cos theta. The theta value is 30, so cos theta would be into Cos theta would be root 3 by 2. So 2 is going to go up. This will become 300 into 2 by root 3, which is nothing but 346 Newton. So this came as the answer of this question. Remember one thing, if the direction of the force is not same as the direction of the axis, okay, if it's not same, then we are going to take F by cos theta. If it was same, then we would have taken F cos theta. Okay, this was a tricky question, but you might have understood it. We got, so I'm going to explain it again. So first we took the friction as over here and mg sine theta. So we equated the force. Got the force as 300 Newton, and it was given in the question to find it along the horizontal. So we found it along the horizontal, which was F by cos theta. F by cos theta is 300 by cos 30. Cos 30 value is root 3 by 2. So we derived the answer as 346. Thank you for tuning into the end of the video. Thanks for watching this video. I hope it helped you to understand the formulae when a body is kept on an inclined body and the friction. You're watching Zip Zap Academy signing off. Bye, guys.